Hello everyone, today we'll be looking at continuity. Continuity is a really important feature of a function, especially when we're doing derivatives. Let's first look at some graphical examples. From first sight, we can see that this function is continuous while this function is not. You probably told that from the two gaps here, which is something we do not want when we are doing continuity. What we want is, say that this is point A. When x is approaching A, we want y to be approaching f of A. Hence, we can get the definition. We say that f of x is continuous at A if first f of A exists. Limit f of x at A exists, which basically is what I just said. When x approaching A from the negative side equals to x approaches A from the positive side. We also need that limit at A equaling to the value at A. Since we may get cases like this, where we can calculate the limit at A, but it does not equal to the value of A. Obviously, this is not continuous. Let's look at some simple examples. This function, is f of x continuous at 0? Obviously, it's not, since f of 0 does not exist. Let's look at the graph for this function. We can see the graph is like this. Indeed, at 0 it is not defined, since f of x will never reaches the y-axis. Let's look at the second example. Is this function f of x continuous at 0? Let's first calculate f of 0. Does f of 0 exist? F of 0 indeed exists, since it equals to 1. Let's calculate limit at 0. When x is approaching 0 from the negative side, let's sub in the value, that is 0 squared, that is 0. Limit x approaching 0 from the positive side of x, let's sub in the value again, that is 0 plus 1, that's 1. So limit, since 0 does not equals to 1, limit x at 0 does not exist. Let's again look at the graphs. You can see there's a huge gap here, so indeed this function is not continuous. Finally, let's look at this third example. Is this function continuous at 0? Let's again check the three conditions. Does f of 0 exist? F of 0 equals to 1. Does the limit exist? Limit x at 0 equals to fx. It doesn't matter in this case which side is approaching, since it's just going to be 0. We can see that the value of f of x at 0 does not equal the limit of f of x at 0. So this function is again not continuous. Let's look at the graph for the third function. Indeed, we have a small gap here, so this function is not continuous. Let's look at an exam question. Continuity is pretty simple to prove, so it wouldn't be worth a ton of marks in your papers, but it is important since after you've proven a function is continuous, you will probably be proving the after you have proven the function is continuous, you can prove that function can be derived at point A. So it's very crucial. Is the function continuous at x equals to 1? Let's first check f of a. Does f of 1 exist? F of 1 equals to 2 minus 1, which is 1. And let's check the limits. F of x approaching 1 from the negative side, or from the positive side, equals to limit f of x approaching 1 from the positive side. Let's sub in the values. That is x squared times minus 2x plus 2, which is 1 squared minus 2 plus 2, which is 1. And the negative side, that is x approaching 1 from the negative side, subbing in the value, that is 2 minus 1, that is 2 minus x, that is 2 minus 1, that is 1. So indeed, the limit exists. And we can tell that the limit when x is approaching 1 equals to f of 1. So we can say that f is continuous at 1. And that's all for today. I hope that helps you understand what the continuity, or what is continuity. And I'll see you next time. Thank you very much.